To solve a 2x2 system of equations, and you have the option of solving it algebraically or with a and for this problem, 2x minus 3y equals 7 and negative x minus 9y equals 49. We're going to do this with a graph first, and then we'll do it algebraically, and you can decide which way you're going to do it. And what we went through before on this stuff, we had a test over getting everything equal to y. So on the first part, it'll go like this. From this first equation, that's what we're working on first. If you leave that minus 3y where it's at and move the 2x over, change the sign, and then divide everything by negative 3, then you'll have it in a form where you can graph it. So if we divide everything by a negative 3, we're left with a 2/3 x minus 7 over 3. In this case, you can change the y-intercept to a mixed number. If you do that, then it's easier to graph. So you just have to think to yourself, how many times will 3 go into 7? It goes in twice, with how many left over? Once, so it's 2 1/3. What we've done here is with this first equation, we moved this 2x to the right side and changed the sign, and then divided everything by a negative 3. Now, of course, negative 2 over negative 3 changes everything to positive there. And then 7 over a negative 3 is minus 7 over 3. But change this to a mixed number so you can graph it more easily. 3 goes into 7 twice with 1 left over, so you put it over 3. This is what we'll try to graph on the graph paper coming up next. But before we do that, we want to take care of this equation as well and do the same thing with it. So we'll move this down just a bit to there and pick up with that equation. So this one, if we move that minus x to the right, it becomes positive. So what we have to do now is go back and divide everything by a negative 9. So that would give us a negative 1/9 x plus 49 over a negative 9. And we have to simplify that a little bit. So the negative 1/9 is fine, but we have plus 49 over a negative 9. That's really minus. So we need to figure out how many times 9 goes into 49. It'll go in 5 times. And that's 45. So you have 4 left over. So what we need to focus on is this for our graph. We want to try to graph that the best we can, as well as this one here. So we'll start with this one on the graph paper. To solve this algebraically, the first thing you want to do is come up with the same numbers on this side. You have a 2 and a negative 1 to start with. What can I multiply this bottom equation by so that I'll have some form of a 2 down there? What would I multiply this term by to get some kind of a 2? So I would multiply by 2. The top one you wouldn't have to change. If I multiply the bottom one by 2, I need to recopy the top one and leave it the same because we're not multiplying it by anything. But on the bottom, when you multiply by 2, you end up with this. Negative 2x minus 18y equals 98. And now we've accomplished the goal of having the same number here and there, except they're just different signs. So if you have the same number, whether the signs are the same or not, then you can add or subtract these depending on what the signs are. What operation would I do to join these two together to make a 0? Yeah, you would add them together. So if I add, that check mark is still in the way from the other work, but if I add these two together, they cancel out to 0. And then I'm going to add negative 3 and negative 18. Negative 3 plus negative 18 is what? We got 3 negatives and 18 negatives. If I add them together, how many negatives are there? Be 21 negatives. And I have 7 plus 98 would come out to be what? 105. So now we have it in a position that we can solve. We can finish out the y here by dividing 105 by negative 21. What's 105 divided by negative 21? Negative 5. Now what was our point on the graph for y? Was it negative 5? Negative 5 sounds familiar. The bottom one looks like it's going to be easier, so we'll plug negative 5 in for y. So x minus 9 times a negative 5 equals 49, and then solve from there. That'll be a plus 45, double negative. And when you move it to the right side, it'll come out to be minus 45. So then we end up with a 4 in the x spot. So we plug back in. Was there a negative sign on that x? Yeah, there was a negative sign. That's what I thought. Something was strange there, so we'll have a negative sign there. That does change everything. I just couldn't see it because of the screen. So yeah, so that's a negative 4. So your final answer is negative 4, negative 5. Now on the graph paper, from the first equation, the slope is 2 over 3 and the y-intercept is a negative 2/3. So if we zoom in here, here's the y-axis, and it's a negative 2 and 1/3. So we'll zoom it all the way in like this. There's negative 2 and negative 3. And what we want to try to do is place a dot on there at negative 2 and 1/3. So think of this as 1/3 and 2/3 there. So it's a negative 2, negative 2 and 1/3 would be right here. That's a negative 2 and 2/3, so we're going to put our dot there. That's the y-intercept, and since I'm zoomed in, I need to make it a little bit bigger. So we'll zoom back out, and we know that the slope is 2 over 3. So we need to zoom back in again. We got to go up 2 and then to the right 3. Alright, so if we go up 2, this is where we're at here. So if I go up just 1, I'm in the same spot right there. And if I go up 2, I'm in the same position in that box as well. And if I go to the right 3, I'm going to go 1, 2, and then 3. Now this may not be exactly precise, but it doesn't have to be for what we're doing. Alright, so what we have to do is connect up those lines. Now I have a line tool on here. Let's see, there it is. I have to let it go first and then try to make it parallel. So here's the line, and then I'll just move it over once I get it to where it's supposed to be. There it is. So that's an approximation for that graph, for that first line. So now we have to go back and look at the other one. So now we have our line, I just need to move it into place. There we go. So now what we're doing is trying to find the intersection of the two lines. Now what point best represents the intersection of those two lines if the graph is somewhat accurate? Negative 4, negative 5 right here. So negative 4, negative 5, and that should be the solution for the system of equations. Now what we'll do is we'll go back and solve that system algebraically and see if it's actually right. And then from there you can determine how accurate your graph is, and if it is, then you might want to solve these by graphing. If not, then you might want to solve them algebraically. See, on this problem, you've got a 5 and a 1 out here on the left, and you want to have them be the same number. They don't even have to be the same signs, but just the same number. So you have a 5 and a 1. Can I multiply this 1 here by something to make it a 5? What would I multiply it by to make it a 5? A 5. So make a note of that out here to the side. You're multiplying by 5, but you're not multiplying the top one by anything. So just recopy the top one, and then on the bottom go through and multiply everything by 5. So you would end up with 5x minus 15y equals 45. That's from multiplying 1, negative 3, and 9. And once you get to that point, if you have the same sign, they're both positive in this case, if you have the same sign, then you're subtracting so that they'll equal 0. So 5 minus 5, that cancels out. But over here we have 9 minus a negative 15, which is really plus now. 9 minus a negative 15, that's a double negative. So you're really adding 9 and 15 to get 24. And then we have negative 75 minus 45. And that would give you a negative 120. And you would solve for y from there. Divide a negative 120 by 24 to come up with negative 5. And once you get a value for y, you have to determine which equation you're going to use back at the top. It looks like the bottom one is easier, x minus 3y equals 9. So we're going to plug negative 5 in for that equation on the bottom. So when we plug in a negative 5 here for the y, we go back and simplify the minus 3 times negative 5, which is plus 15. And then move that 15 to the right, make it minus. 9 minus 15 would be a negative 6. So the x number goes first, y number second. Your answer would be negative 6, negative 5. Here it is to where I gave a hint. I already picked out 10 and 7 that we're going to multiply by, and this is the result when you multiply by those numbers. And since you have two positive 70s, that means that you have to subtract the two equations. So when you subtract here, it goes to 0, and 50 minus 28 would be 22y, and then a negative 470 minus a negative 448 is the same as plus 448. That would be a negative 22. So when you solve it out for y, you'll have negative 22 divided by 22, which is a negative 1. You'll have to go back and plug that negative 1 in to one of the top two equations. I'll try the top one. So if you plug in a negative 1 for y, you'll go back and simplify. That would be a negative 5, but really a minus y or minus 5 in there. And then you'll move that to the right side and make it plus 5. So negative 47 plus 5 is a negative 42, and divide that by 7 to come up with a negative 6. So your final answer should be negative 6, negative 1. Alright, so we worked this one out to here as a boost to this point. So when you divide 154 by negative 77, you should come up with a negative 2. And then plug that negative 2 back in, probably to the top equation. So we'll recopy that one. And 3x minus 5y equals 28. And if we put in a -2 for y, we'll go back and simplify to get 3x plus 10 equals 28, and then move the 10 to the right and make it minus. 28 minus 10 is 18, and divide 18 by 3 to get an answer of 6. So it's 6, -2.